Hi guys, today we're going to do kind of an alternative to a lab that we've done for quite some time. Actually, I did this one when I was in school. It's the diffusion lab, so we're looking at how particles of various sizes can move across a membrane. And so we're going to use iodine, or a source of iodine, IKI, iodine potassium iodide, and starch, which is a really large complex carbohydrate, and let those combine or react, and the result will be, if they come in contact with one another, will be a purple color. So it will change from the starch being kind of white, iodine kind of, depending on how strong it is, a kind of a yellow, orange to brown, and you mix those together in a chemical reaction, you'll get purple. So we're going to try to get purple, or see if we're able to get molecules to move across the membrane and create that color. So we'll see. So before we do that, we need to review a couple of things. The one thing I want to make sure is that when you finish a lab, you learn something. We don't want you to finish the lab and say, "What'd you do?" "Well, we made purple." "What do you mean you made purple? How did you get that? What happened for that to happen?" So what did you manipulate, or what happened in the lab? What did you actually learn? Not just, "Oh, I saw a cool purple color." So we're going to go down through here. So I'm going to read to you basically the lab. I'm doing this on my laptop, so I'm not able to write in the answer, so you'll have to just listen carefully, and you can stop and pause the video as you need to and go back. But here we go. Number one, diffusion is the movement of molecules from a high concentration to a low concentration. So you're going from an area where it's very crowded, and it's spreading out to an area where it's less crowded. And that happens naturally. That happens free, does not take energy. Number two, the molecular formula for iodine potassium iodide is IKI. That means it has blank atoms of iodine. So if we look, I, K, and I, we have two I's, so we're going to put a 2 in there for A. So we have 2 atoms of iodine, and there's only one K. It has no subscript, so we're going to say 1. So 2 plus 1, IKI has a total of 3 atoms. Number 3, the simplest molecular formula for a starch is. So what they're saying there, without saying, is that there are lots of different starches. And so the simplest of those would be this C12H20O10. C12H20O10. How many total atoms does it have? So we just have to add them up. And since we have 12 of the carbon, we've got 20 more that are hydrogen, so 12 and 20 gives us 32. And then we add another 10 here for the oxygen, so we're up to 42. So number 3 would be 42. Having done some simple math, which molecule is bigger? Now that you've done the math, it's pretty easy. Most of you know the alligator points to the 42 and away from the 3. So which one is larger? Starch. Number 4 would be starch. Which molecule do you think, or hypothesize? When we say think, what we really mean in science is hypothesize. So which molecule do you think will be able to move through a membrane more easily? Whatever you think, you put there. All right, come on down here. So the next concept we need to cover is molecular structure of any matter or a substance. So every substance has a unique molecular structure. There are holes in every structure. Let me say that again. Every substance has holes. If a substance has holes in its molecular structure that are bigger than the molecular size of another substance, then that second substance will be able to travel through. So here's an example. Have you ever had something you threw in the back of the freezer, or you have a deep freeze and you go to clean out a shelf and you say, oh, there's, some, whatever food it is, it might be some old meat that got thrown to the back and things kept getting thrown on top of it. You pull it out and you see it's several years old and you try to eat it, but it has that freezer burn taste to it. And so what happened is, for something to become freezer burn, is that the ice, the water, frozen, the ice and the food, it went through a process of sublimation. It went from the solid water, which is ice, straight to the gas, or water vapor. It skipped the liquid altogether, went to the gas, and managed to wiggle out through the pores in whatever container or bag that the food was in. And as all of that moisture slowly gets out of the bag or container, then that's the freezer burn. So it's really a dehydration, slow dehydration. And that's how a freezer or refrigerator works. Is one of the ways is it expands that air and it sucks out all the moisture. All right, so even a substance that you look at and you say, oh, it's airtight, you can breathe into a bag and you're like, you can't get any more air out of it. It's once you seal the end, it seems like it's pretty airtight. It's not. There's just teeny, teeny, tiny holes. So how many atoms are in a molecule? That's going to come into play here in a minute. How many atoms are in a molecule of water? So now we've practiced up above. We just kind of look at our subscripts down here and add it together. So we have 2 hydrogens and 1 oxygen. So a total of 3. So the answer is 3. Not a very big molecule, only 3 atoms. So it takes a pretty small little pore in a substance to prevent the water from escaping. Okay. All right, so let's look at some of the materials for the lab to set it up. We need a cup. We need 2 packing peanuts, but they're not just any packing peanuts. They can't be styrofoam. They are made of starch. Remember, the lab is starch and iodine. We'll need 10 to 15 drops of iodine. And again, we're using IKI. It's also called Lugol's solution. A baggie, just a plain old cheap baggie. Doesn't have to be Ziploc. Matter of fact, you're probably better off having the cheapest one you can purchase. And a small piece of tape. You got those things and you're ready to go, ready to set this up. So the procedure, we fill up the cup with about half full of water. Then you take the baggie, fill it 1/3 or so of water. Okay. Place the 2 starch peanuts into the baggie. And then you take and just use your hand and kind of knead and squish the starch peanuts around, and they will slowly kind of dissolve and break up. And they don't really totally dissolve. You can see I kind of laid it down here on the desk, and there's still some chunks of it's white stuff, but there's also some inside here that you can't really see. You can see some tiny little spots. So it's dissolved enough that we'll get the effect that we're looking for. Then we're going to add 10 to 15 drops, as I said earlier, of our IKI into the water. So we're going to have our iodine in this cup, and we're going to have the starch in the bag. Tie a knot in the top of your baggie. Place the baggie in the water, but be sure to leave the top wrapped or folded over the top edge of the cup. You want to prevent the top of that bag from getting down into the water. You want to keep it out to preventing leaking. Tape that top of the bag to the outside. Oh, it says of the bag, of the cup. Okay, so it's gonna look like this. All right, so our IKI kind of settles out a little bit, and then here is our starch inside the bag, and I've tied a knot and put the bag over so the top of the bag is outside the cup and it's taped on to prevent any of that from spilling out. Wait an hour. Sometimes we'll wait for a day. And before we go any further, let's let you hypothesize. So go ahead, once we do this, I want you to pause, make sure you write down a hypothesis. It can be an if-then statement if you're more comfortable with that format, or not. What do you think is going to happen? We've got IKI in the water in a cup. We have starch in the water in the bag. We'll wait an hour. What's going to happen? All right, so it says day 2, an hour later. It just depends on our schedule and what works. We take a picture and see what it looks like. Here's what we get. So when you first go to look at the cup, you see the bag still taped down, appears to be darker inside than the solution of IKI. You pull up the bag and you can see that it's a very dark bluish purple, almost looks black inside there, and IKI here. What happened? Why did our starch turn so dark? Okay. Something was up with the formatting here, so I've got some empty space to answer that question. I'm not sure why it would not let me move these lines up, so you can just write in the space directly under number 3 there. Rather than go down, if you like the lines, go down and use the lines. That will be fine too. Okay. So what happened? How did we get a color change? And if you're still thinking, maybe go back and, little hint, go back to the top and look at our intro information. And really, the way I set things up, if you look at the title of the module or the title of this particular lab, it gives you a lot of good information. Hint, hint. Yeah, when you finish this, go ahead and submit it, and then there's a short quiz afterwards.